Shut up and sit down.
Well, hey everybody, welcome to another episode here of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, and I am your host on today's podcast. So it's been a while since we've done a real thorough podcast, so welcome back to the podcast. If you haven't heard any of our lengthy ones lately, obviously we've been doing a lot of these codes in 5. If you're interested in those, again, I talk really fast on those. And people ask me, well, it's code in 5, so I've got, to be honest with you, I've got 5 minutes or approximately 5 minutes to actually get the message out. So it makes it more difficult to do that. So obviously I end up talking faster. So if you like that type of content, make sure you check it out. It's code in 5, and basically we're breaking down the code in 5 minutes approximately, or less. You can also get all those as well on all of our popular podcast listening platforms: Spreaker, Spotify, Deezer, Apple Podcasts. Make sure you give it five-star rating and thumbs up, and we'd love the feedback. If anything we do helps you out, let other people know. We appreciate you. Again, with the limited, I think what we've seen lately is podcasts came in vogue, and I've been doing them since 2004, to be honest with you, but it's before they were called podcasts. It was under something called 1,000 Mics, which was a unique platform, but people have been doing these things for years, and it seems like it hit its peak, and a lot of the shows that do electrical stuff, which is some great stuff out there, drop off, and some of them have just gone under there, and, I guess some of them are a bit, just talking and rather than not code, and of course, we've been consistent. We're code-based. We talk code, but we also have the Electrician Live show, which has been over a year now, and it's going strong, and it just talks about generally any topic is fair game for that show. So anyway, thanks for listening today on this podcast. What we're going to do today is there was an article that came out recently in NEC magazine, which is, by the way, is a great magazine. I don't know if you get a chance to get it. There's some great stuff in there. There's always some great articles by Mike Holton there. There's really good content throughout. And again, people contribute to writing articles to it. So it's a great publication, and hopefully you subscribe to it. It doesn't cost you anything. But from time to time, they'll, kind of regurgitate an old story, different things, and bring it up. And sometimes I see some of these things and I'm thinking, great material to be able to talk about something, especially when we're talking about maybe changes or how it's modified or adapted from maybe something that was required back in the 2014 code. And of course, then you got the 2017, then you got obviously the 2020, and then we're working heavily on the 2023. So it's just kind of great to kind of reminisce back and see if things are still relevant, especially when an article is written all the way back in 2014, right? So that's what we're going to do today. The article itself is the 10 biggest grounding mistakes to avoid. And I'm going to elaborate a little bit on it, give some code context to it. But it's a great article. Check it out. If I can find the link again, I just kind of wrote down the key topics, but I'll try to post it in the comments if I can find it. But if not, go search for it under ECNM Magazine. It's a great article written by David Hers, I guess that's how you say it, Hers. And so if there's anything I disagree with it, I'll let you know in this podcast. But other than that, always love the contributions that people make to help other people learn. And so this is one of them. So I'm going to kind of be paraphrasing it based on the subject line of what the failure is or what the problem that people might have, so that you can kind of learn from it. And I'll give you code context to it as well, kind of give you some additional commentary. So the first one that they talk about in that article, I guess you will, is, and I should say the article actually came out August 20th of 2024, in case you want to search for it by that method over in ECNM. But again, great publication. Mike Eby's the publisher, does a great job. They do a really good job keeping the industry up, everybody up on trends and things that are happening in the industry. So check them out. Again, I should mention free subscription, so you don't have to buy anything. So, all right. So the first thing we talk about is their first thing that they talk about is Failure to install a second ground rod where required. Now, interesting thing about the National Electrical Code is if you're going to use ground rods, and again, typically you've got a list in 250.52a, right? There's metal underground water pipes. There's metal in-ground support structures like the I-beams in the ground or in concrete encased in the ground, either or. 10 feet or more in contact with the earth, whether it's encased or not. You got concrete encased electrodes, which is very common, that typically uses the building steel, rebar, half-inch diameter rebar, in the footer or foundation, at least 20 feet of it. Of course, there is an option as well for bare copper if you want that, not smaller than 4, still has to be 20 feet, okay? But it's basically, you can have the bare copper. And it gives you instructions on that as well for how to that's to be installed. Ground rings, don't see those as much, but again, you can have a ground ring. It's not smaller than 2, could be larger depending on the engineer who designs it, but that encircles the entire building, not halfway around the building, not 3/4 of the way around the building, but entirely around the building. And then of course you got your rods and pipes. And then it goes on to other listed electrodes. If they are listed, they have a listing to serve that purpose, then you can utilize it. Of course, you have plate electrodes, which again, I don't see plate style electrodes very much. And they're required to be not less than 2 square feet of surface area to the exposed soil. I would argue that a 1 foot by 1 foot is basically, you got 2 sides, right? It's in contact with the earth. But anyway, it gives you instructions on that. And then, of course, then it says other local metal underground systems and structures. That could be like underground metal tanks. There's a lot of surface area there. Potential underground metal well casings that are not bonded to the original metal water pipe. So there's other options out there. You need to work with your local AHJ and see what you have on site. I think most of the time, what we're going to have is that the metal underground water pipe or the metal in-ground steel or the concrete encased electrodes, those are things that are inherent to a construction project, right? They're going to either be there or they're not, right? Because a part of the construction. The other ones are something that's going to be added later after the fact. If the first 3 aren't there, then you're going to have a grounding electrode system. That's what 250.50 tells us. So we're going to have the other ones. So in this case, again, that was a big segue to talk about these ground rods. So when you're talking about ground rods, you follow all the rules in 250.52A5, letting you know that they're at least 8 foot in length. And again, it ends up telling you that you can use pipes or conduits as long as it's trade size 3/4. And it gives you those type of parameters. And with the ground rod, it's saying, look, the ground rod has to be at least 5/8 of an inch unless it's listed otherwise. And if it has a listing, it might be less than 5/8 of an inch, but it's still, for all intents and purposes, equivalent. Again, it's all about the listing. But the thing about the ground rods in this one that it's talking about is the failure to add the second one. And the reason for that is when you go over to 550.53 and you're looking at A2, and of course I should remind people, I'm looking at the 2020 edition. In case you're wondering where I'm at. I'm at the 2020 edition of it. And number 2 talks about supplemental electrode required. So interesting. All of us are probably pretty savvy and familiar with the fact that when you have a water pipe, that you're required to supplement the water pipe, right? We're all probably pretty savvy with that. That's a requirement under 250.53D. for a metal underground water pipe, and it continues on to item number 2, which talks about supplemental electrode required, right? And so in this article, of course, you'll see that refers to when you got a ground rod and you have to have a second one, it talks about augmented. Basically, now we call that supplemental. But in this case, because there is such thing as an auxiliary grounding electrode, which would be, for example, doing it to a lamp, to a post light in a parking lot, which you're required to take an equipment grounding conductor there to clear a breaker, but you're not required to have ground rods there, although some engineers specify it. Since it's not required by the code, but you're permitted to do it by the code, then that would be an auxiliary electrode, okay, which doesn't require it to meet all the other requirements for the ground rods, the typical ground rods that we do for a building. but you can have it, right? And it's also applied sometimes to equipment in the building due to vibration, static, electricity, and all this kind of stuff, dissipation, right? We're talking about the ground rods to, let's say, your house. So what the code says is at 250.53A2, it says supplemental electrode required. A single rod, pipe, or plate electrode. Now, notice that the 25 ohm requirement that we'll be talking about really covers rod, pipes, and plates. And I think a lot of people lose sight of that. We're so used to saying 25 ohms for a ground rod, but we don't think about the pipe and we don't think about the plate, right? It's so focused on the ground rod. But here's what it says. It says a single rod, pipe, or plate electrode shall be supplemented by an additional electrode of the type specified in 250.52A2 through A8. Of course, A2 is being the in-ground all the way through 8, which is the other listed. You notice it doesn't say A1 because you don't supplement this electrode with a underground metal water pipe, which is required to be supplemented anyway. Kind of makes sense, right? But all the other ones you could utilize. And it says the supplemental electrode shall be permitted to be bonded to one of the following. Number one, rod, pipe, plate electrode. So again, that's when you take your grounding electroconductor to the first rod, right? The second one is allowed to be bonded to the first one. So a lot of people get that confused too. They think that you got to be continuous from the panel, grounded terminal bus, down to the electrode using a grounding electroconductor. And if you're putting in 2 ground rods to meet this rule, which we hadn't looked at the exception yet, to be able to go from 2 down to 1, then what happens is they typically think you got to loop it through the first one to go to the second rod, because all of that is the grounding electroconductor. Actually, it's the grounding electroconductor to the first ground rod. It's a bonding jumper to the second ground rod. So you can stop theoretically at the first one. And I say theoretically because most people continue on through, so they only have to use one connector. Okay. But you could stop there if you wanted, and then put another connector, or clamp, I should say, and then go from that rod to another rod, right? So what they're saying, basically the article, is many people are installing a single ground rod, and they're not following these supplemental electrode requirement. They're not putting the second one. And there's a good chance that they're not even testing to see whether or not they have 25 ohms or less or not in order to eliminate the second rod. And the reason I say this is because if you look at 250.53A2, and you have all the locations you can connect to, okay, we won't go through all of them. It's 1, 2, 3, 4, and 5. But we are going to look at the exception. The exception says if that single rod, pipe, or plate grounding electrode has a resistance to earth of 25 ohms or less, the supplemental electrode shall not be required. So you could go with one. So anytime that I see a dwelling that only has one grounding electrode, I'm assuming that somebody did the testing and it was 25 ohms or less. And that's why they only had to have one. So calling it a violation, again, is subjective. That is, subjective to, we don't know if anybody did the testing or not, right? So, and we're gonna take the high road and assume they did, but chances are most do not, and they just install one ground rod. So that's probably what they see as a failure, is to install a second ground rod, because nobody really knows whether or not it's 25 ohms or less or not. So you just put the second one in. Okay, so that's kind of what that one covers. And so that's kind of the first mistake that they like to talk about. Okay, so the next one that comes in their list of mistakes that people make when it comes to grounding is dealing with satellite dish, DirecTV, Dish Network, all those type of things. Some of this new internet systems that are coming over the dish type of thing. The biggest issue that they appear to call out is the fact that many people are not giving a proper termination for these folks to be able to take their connection, right? So they're required within Chapter 8 for their installation, whether they follow this or not, whether there's an inspection or not. The issue that with most newer installations is that people remember back in the day when all you had to do was just, as long as the grounding electroconductor was exposed, let's say the 6-gauge copper that's going down solid, by the way. Going down doesn't have to be solid, can be stranded, but going down to the grounding electrodes, say ground rod, if you will, as long as it was exposed to there, then you could connect onto it with a split bolt or whatever, and they were done. The code actually requires an intersystem bonding termination device installed in all new installations. And there are some provisions for older installations and some allowances for buildings that have an older installation that's already in place, and you're adding something new to an existing building. There's allowances in there. We're not going to talk about that in this episode. But one of the problems is that you have a lot of these dish networks, and I'm not singling them out. I'm just saying dish networks and direct TVs and other type of satellite systems or other type of things. And they really don't have the location to be able to make that connection to ground their system. And so they end up not doing it. And so the electrician has to, especially if there's communication at this building, then you have to provide them a way to make this connection. So in the National Electrical Code, we'd be looking at 250.94, and that would be A. Of course, we have an A, which is for intersystem bonding termination device. And of course, we have a B, which is other means. The key thing to remember here is the A is only for communication. That is it. It's not for taking things like CSST to this device. That's the bonding of corrugated stainless steel tubing. It's not for PV systems to come to a common location at the service point. That is not what it is for. It's for communication systems only. So you have to supply that. And that's the electrician's job to supply that, because that's in our code. Now, we probably aren't going to be the ones that come back later to make sure that the communication companies did their job right? And the chances are they don't get inspections. But we, as at least electricians, we have to afford them the ability. Because when something goes wrong and you didn't give it to them, it doesn't matter if they did something wrong. Lightning strikes their system and it doesn't dissipate or doesn't matter. If we do something wrong, it's always going to come back on us, the electrician. So because the communication people are going to say, dude, I had nothing to connect to. I'm not an electrician. So we have to make sure we do our due diligence and get it right. So in this case, 250.94A talks about the intersystem bonding termination. It gives you the parameters for it, where it has to be. And I think that that's probably true that even today, many people do their electrical system and they don't think about this component and be able to make it. Now, there is another option under B, under 250.94, and that option is called the other means. So this would allow me to put an actual bus system there, like a bus bar with support structure to the building. And as long as that bar was 1/4 inch thick by 2 inches wide, and of course it had sufficient space to be able to have at least 3 terminations for the communication. Of course, it could be bigger for the other systems that might want to use it, because in this other type of termination here, you can use it for the communication like we did for the IBT in A, but you also can take other things to it, like corrugated stainless steel tubing, CSST bonding, or PV or something like. You could bring other systems to that point, okay? But you have to have at least the 3 terminals for the communication, and then, of course, it's like you say, okay, I'm going to give you more space to make other connections if you want, but it has to be sufficient to make the connection for at least the 3 terminations for communication. In addition, now, that means that if there's going to be other connections to it, then it has to be adequate length, okay, in order to be able to accommodate that. So anyway, you have options here. You can use copper or aluminum bars. Again, people question that all the time, but it's perfectly okay. And of course, then you'll see the exception after that for both the IBT, which is the one only for communication, and then the other means, which is the bus bar that you would install, which is very common to like what we might do in a data center where we're bringing all of our bonding grid and everything together to one common location. It's a very common application that people do. Just remember that you do have an exception to this. Okay, where there's no communication systems at the building, or it's unlikely that they will ever be used at this building, then you don't have to have these connections or provide these. But as an electrician, I really don't know. I know with the house, you're going to have communication. With a detached structure, I just don't know. But I would tell you it's better to be safe than sorry. They're inexpensive, and many of them clip right onto the grounding electrode conductor and provide you the number of terminals you need. So it's probably better to do than not, okay? So if you're following along in that one, obviously that is 250.94A and B, and that is the issue where people are not putting in the ability for the communication systems to bond at this common location at the service, right? So, or at the meter location. So this is obviously something that people don't do. So that is a problem that has been highlighted, and that is in this article one of the grounding mistakes that people make. They're not taking those things into account. Okay, the next one that we run into is probably, to me, obviously this list is not like from the worst case scenario to the most dangerous to the one that's the lightest, not as, maybe it's just a code thing and not a safety thing type of concept. So this one is, to me, is very much safety driven because this is the improper connection between an equipment ground and the grounded conductor downstream of the service. So this is a violation of 250.24A5 where you're making connections downstream. So in a panel, for example, service panel, you all know that you're going to take and combine your grounded conductor, which in many cases is a neutral, and you're going to connect the equipment grounds from your circuits downstream, whether it's a feeder or branch circuit, together on the same common bus or multiple buses that are tied together, however your layout is of your panel structure. The key here is they're directly connected to the grounded conductor, but it's also connected to the grounding electrode conductor that goes to the electrode. Everything in the service, it's all tied together. Once you get downstream from that, there is this isolation that takes place, this separation, whereas you do not want the grounded conductor to come in intentional contact with any grounded parts, okay? So the metal parts, the cabinets, things like that. So this is why we refer to a remote distribution panel, which is downstream from the main panel, main service equipment. Maybe feeding a panel that's in the basement or something like that, that we now run 4 conductors for that because we want to make sure that we isolate the grounded conductor because it always carries current. There's no way it's going to be perfectly balanced. So it carries current, and we do not want that in contact with metal parts. We do not want the metal parts to potentially intentionally carry current. The metal parts are connected to the equipment grounding conductor that we're required to run, and they're not normally current-carrying parts, although they can carry current under a fault condition, ground fault condition, but that's not the norm, right? That's not the normal, and that's when we're doing an installation, we're designing the system so that we don't have those conditions. So you separate that downstream. Now, barring some allowances for existing applications in 250.32 for existing buildings that are remote buildings, you get your rules on what to do there, or something like ranges and dryers that fall under an existing conditions under 250.140, for example. Barring those those allowances, I should say, for past history, now you're required to have 4 conductors when you leave. Okay. Now, not going in too deep to that, but the problem that we have with people that not typically is our trade people. These are people that just are DIYers or people do it yourself. They start thinking about these circuits downstream, the branch circuits and feeders, and they're thinking, well, wait a minute. Why do I need to run an equipment ground and a grounding conductor? Because they don't understand the principles, which is why I recommend to everybody to get my grounding and bonding book, get our course for that. It's a great course that teaches you all the fundamentals, and it's not so confusing because it starts at the very beginning, right? 250.4, 250.6. It works your way all the way up so you can follow along in your code book. It's just a more logical way to do it. And of course, we quiz you on it. So if you're interested in that, check out our grounding and bonding program over on masterthenec.com. But the key thing here is they look at it and they go, well, wait a minute. If the equipment ground and the grounded conductor goes back to the same bus bar in the panel, what's the difference? Well, will the circuit work? Absolutely. However, due to the fact that we are required by the code to bond all non-current carrying metal parts to the equipment ground, what happens is everything is tied together, and that is a beautiful thing when it comes to clearing a ground fault. It allows a breaker to have a low impedance path back and clear the device very quickly. So it's a safety thing. We don't refer to the equipment ground as a circuit conductor. It's a safety conductor, if you will. Whereas the neutral or the grounded conductor does carry current. And if you intentionally connect that to an equipment ground, or you intentionally connect that to a metal enclosure that is connected to an equipment ground, now what you're doing is you're circulating current on metal parts. And people think that these are normally non-current carrying. And then they end up touching it or come in contact with it, and they increase the risk of injury. Okay, and in worst case scenario, electrocution, which is death. I see these things all the time. Johnny says that he was electrocuted, and he says, I got electrocuted, and I want to tell you how to not get electrocuted. I'm like, dude, if you got electrocuted, you're dead. So obviously you didn't get electrocuted. You did get shocked, and there's other ramifications for getting shocked. If you are working on something that's an improper case to neutral, and now you're on a ladder and you're doing it, and you get a shock, you could fall off the ladder, and you could indirectly get injured by the fall. And it was caused by an improper case to neutral that put current on non-current carrying metal parts that weren't supposed to be there. So it's very important that when we're installing a system that we understand that once we get away from that service, that we want isolation. Now, barring any rules, transformer secondaries, and certain things, depending on where you put the supply side or the system bonding jumper and all that, look, barring the general rule here is, well, not barring it. The general rule here is that we do not want equipment grounding conductors connected to grounded conductors anywhere downstream of the service disconnecting means. And if you remember that, even as a minimum, and you're not overly electrical person, then you're going to fundamentally have a safer system. Safer than you would have. It's not a perfectly safe system, but it's better than you would be. And the code is a minimum standard, right? So that is one of, they list as one of their big issues, and I believe it is the violation of 250.24a5, improper case to neutral connection downstream of the service. Barring, again, any of those rare allowances, this becomes a big issue. And so, again, agreed 100% that this is something that is an issue and it needs to be addressed. And so every educator out there really needs to push, and I believe you do, the need for separation and isolation between the equipment grounds and the grounded conductors downstream. Definitely. And that's in boxes and everything. The funny thing about that, though, is even if the equipment ground happens to touch the grounded conductor, in most cases, it's not going to do anything, but it is going to impose current on the bonded components. But as far as a normal breaker, it's not going to trip. So again, you do have it. Now, with some devices like AFCI devices, it will detect this and it will trip. Some GFCI devices, obviously, will trip if the current's traveling in another path than its intended path. Of course, you don't always have to have an equipment ground for a GFCI to function. So again, we have some allowances in the code with that. So just think about it and understand that we want to keep that separation anytime we get downstream of the service disconnect. Okay, now the next issue that they talk about in this article is called the failure to properly attach an equipment ground. They say ground wire, but we should use proper terminologies. Failure to properly attach the equipment grounded conductor to the electrical device. So this is kind of referring to 250.146, which is talking about connecting receptacle grounding terminals to an equipment grounding conductor in the 2020 edition. Now, obviously, there's some grayed out portions here in the 2020, so this is a change. You got to remember, this is from 2014, so some things have changed. Some terminologies have kind of changed, altered a little bit, so in all fairness. But the concept here is, look, if you have an equipment grounded conductor and you're taking it to a device, barring any allowances like for surface mounted boxes, where you might have a direct metal-to-metal connection from a device on a yoke, and you have some allowances here, and that's really what 250.146a is talking about. It is basically surface-mounted boxes. And, of course, then you've got B, which is talking about contact devices or yokes, okay, which are talking about basically if you have a flush-type box and you can have an equipment bonding between the device yoke and actually the metal box, then you would achieve that bonding requirement. But under the general rule, you don't have that issue or that ability to do that. Let's say for a non-metallic box and you're going to put a device in that box. So let's keep it simple. So what we're finding is a lot of people will actually take a device and do a lot of connections and terminations, but then once you get to the box, they will not make the equipment ground and conductor connection. So it's important that we express to people that 250.146 has grown over the last couple cycles for clarity. A lot of new information, it's there. It is all about establishing an effective ground fault current path. You do get some options on how to do this under 250.146A and B. Of course, C is dealing with floor boxes, and then D is giving you some assistance on an isolated ground receptacle. And then we also should not lose sight of 250.148, which is establishing the continuity of the equipment ground conductors and the boxes. For many years, the boxes weren't actually listed as an equipment ground conductor, even though we always made connection to it and we utilized it. So we have reaffirmed the fact that the box is an equipment ground conductor, especially if it's imposed, or I guess I should say interposed, in the equipment grounding conductor system. Okay, but the clarity here is that people are not making proper connections for equipment grounding conductors that are run with the circuit. Again, we call those a safety conductor. Circuit conductors are the blacks, the whites, the reds, those that are intentionally carrying current. The equipment ground is not designed to intentionally carry current, but it has to be sized in accordance with table 250.122 based on the size of the overcurrent device that's actually protecting the system or the circuit. In doing so, it allows an effective low impedance ground fault current path back to the source that allows that overcurrent device to function properly. If you do not use the equipment ground, and again, you as an electricians probably say, that's Paul, I'd never do that. I get it. But obviously, you have to have been into installations where you pull a box out and you just shake your head because people aren't using it. So it's easier to send the message out there and say, look, use the equipment ground, connect it to the device. If the code gives you allowances for surface mounted boxes or direct contact, if you bond the box and not having to take it to a self grounding type receptacle, but as long as it connects surface to the metal box, then everything is, kosher at that point, then that's okay. Other than that, I would always tell people, if you don't know what's going on, then you side on the error of caution. And if you side on that side, then you're going to take the equipment grounding conductor and you're going to make direct connection to the green screw that would be on the receptacle or the switch, unless the code permits you otherwise. And we're not going to go into all of those allowances. I encourage you to read 251.46 A and B, get a better understanding of contact yokes to metal boxes or different aspects when we're talking about metal to metal contact. And depending on the type of cover you have, it's a really good read. 250.146 A and B is really good. And I tell people all the time, if you want to get better at something, target something. And that is definitely something you want to target, right? Okay, so that covers that one. Again, use those equipment grounding conductors. They serve a role. They serve a function. It's a safety circuit. It allows these overcurrent devices to clear. And it's so critical, and it's required that we have one present. All right, so the next one that we want to look at, it's based on this article, is something I really didn't think about. So, we put in new installations. We're always putting things. We're being very diligent about the connections we make and understanding that when we make a connection of a raceway, especially if the raceway is being utilized as an equipment grounding conductor, how important that connection is to the cabinet or the junction box. And we really think about that. And of course, we follow all the rules that we know of when we're dealing with service applications, 250.90 and 92. We realize that we're going to have to do something if we have concentric or eccentric knockouts. We get that. We end up understanding when we need bonding jumpers and not. And again, on the load side applications for feeders, for example, we understand that lock nuts can make that connection to those raceways, to the cabinets and everything. We know all this, but we really don't think about what happens in a situation where we come in as an electrician and we're remodeling something or we're changing something or we maybe have to take something loose to do something and we're putting it back together. making sure that we follow our due diligence in putting something back and maintaining that effective ground fault current path. I mean, after all, we're talking grounding here, right? So we're trying to make sure we maintain that. Of course, an aspect of grounding is bonding and making sure that all those metal parts are adequately connected together. I don't know if I said that right. Adequately, is that right? Connected together in order to make sure we establish an effective low impedance ground fault current path. And it just reminds me of the typical grounded systems that we deal with in 250.4a. All of the items that we're talking about, system grounding, equipment grounding, bonding of electrical equipment. And then we've got this 250.4a5, which is an effective ground fault current path. So when you go in and you maybe alter something or make a change to something and you pull it loose, taking the same due diligence and putting it back and make sure that we maintain that effective ground fault current path is so important, because all these things that are imposed into the system, whether it's the boxes, the cabinets, the raceways, the wire type equipment grounding conductors that are making connection to these boxes, cabinets, raceways, and things like that, that we're going to actually clear an overcurrent protected device when necessary. It's so important. So I think it's one of those things that they kind of allude to is, there is this occasion where you might have something happen and you have a ground fault, or you have a situation where you have energized metal parts that are not supposed to be. And the integrity of this tying everything together and putting everything at the same plane, if you will, allows the operation of an overcurrent protected device, whether it's a fuse or a circuit breaker, to effectively react. And this is so vital. So I think one of the messages is making sure that if you're doing any work and you're working on something, that you reattach in the same manner that you would if it was a new installation. So for you remodel folks, people that are going in, and maintenance folks, it's so critical that when you're not the first hands on it, but when you're working on it, let's say, and you've removed something or loosened something and you put it back, that you make sure that you recheck the integrity. That's the key. If you notice something like an impaired connection, or one of the KOs are coming out of a box where you're reinstalling something and you're like, oh, this just looks Yankee here. This just doesn't look right. Then you need to make it right, because the integrity of the system is why it's so important. The whole grounding system and what we do with bonding and everything, and the integrity of it is so important to the operation of an overcurrent device, that it's just critical that we do so. Not to mention the fact that even an equipment grounding conductor that's being used as a grounding component, because again, it helps us for voltage stabilization through the system, but also again, remembering that it is serving multiple roles, not just the grounding role, but the bonding role. Okay? That's so critically important for us to understand, especially when we're reattaching or adding something new to a system, or pulling something loose to make a change, let's say to maybe a disconnect, and we're putting it back, taking the same integrity to those connections, remembering that this all has this base foundation in 250.4, A for grounded systems, B for ungrounded systems, but making those connections are critically important. And again, it's probably overlooked, and people take those things for granted. Okay. I'd also say, and you can say you can agree to disagree on this, but as an electrician, anytime I went into a project to do some work and I noticed something which might not have been related to my work, but it had something that impacted the integrity of the grounding system, that anything that could have put 250.4 in compromise, I would have to correct it or fix it, or at least bring it to somebody's attention as an issue. Because again, it's slapping you right in the face, and it's not providing that low impedance effective ground fault current path. It just can't, because if you look at it, it could be, again, a damaged KO, and it's not making that adequate connection or something, and you need to address it. So don't just put the blinders on. I know you're thinking, well, this creates extra work, but get paid for that work. If a customer directly tells you, don't worry about it, okay, then you have to make that decision at that point. But at least I would document that even on my invoice or whatever you'd say, I'd say note, noticed an issue with this was directed to disregard by the owner or whatever. My point is, if you see something, fix it. And to what extent you can, obviously. Again, it's obviously a very general statement for a broad problem, but something to think about it. Okay? The next thing that we look at that they talk about in their little list here is improper grounding frames of things like electric ranges and clothes dryers. Now, we've talked about this. I kind of said this indirectly when we're talking about other aspects of some of the allowances for like equipment grounding conductors and the grounding conductor being utilized. And remembering that we don't want to have a violation of 250-24A5. But in this case right here, before the 1996 edition of the NEC, it was very common practice to run a 3-wire system cable to, let's say, a receptacle for a range or a dryer. Very common. And basically, the way that would in doing this, the bonding of the frame would be connected to the grounded conductor. And at that point, you potentially energize the metal frame. So after that, that was from the 96 edition on, you couldn't do that anymore. Although 250.140 still has a existing allowance for those that were allowed at the time it was originally installed. It's not something that we're going to do today. But I think what probably happens today is that a lot of people that have been doing this for many years probably aren't fully up to speed on what the rules are today. And you would think by now inspectors would have, or people would have failed an installation or two by now, maybe. And that's where they realize the issue. But 250.140 is pretty clear. It says frames of ranges and clothes dryers. It says frames of electric ranges, wall-mounted ovens. And you know what? Incidentally, we should probably put a public input, and it's too late now, and to change this title because it's not just frames of ranges. Obviously, it says frames of electric ranges, wall-mounted ovens, counter-mounted cooking. We should probably change this to, cooking equipment or however it's listed, I guess. I don't know. I'd have to look. How it's listed in 220. Let me look real quick since we got the time. I mean, again, for those out there that do like to put in the public inputs and public comments and all those kind of good stuff, I just want to look real quick. And I hate to take your time up for doing that, but I want to look real quick. And so it says electric cooking appliances in 220.55. Probably the best to title this frame instead of frames of ranges and clothes dryers, because it makes reference to ranges, ovens, cooking units, and things like that. It probably should say electric cooking appliances and clothes dryers. So anybody out there that wants to do a public input for the 2026 edition, whenever that comes, there you go. Unless, of course, I missed it, but I am on that code panel, and I don't believe we fixed it. So anyway, just a suggestion. But at that point, what the code says under 250.140, it says the frames of electric ranges, wall-mounted ovens, counter-mounted cooking units, clothes dryers, and outlets or junction boxes that are part of these circuits for these appliances shall be connected to the equipment grounding conductor in a manner specified by 250.134 or 250.138. So, obviously, prior to 1996, there wasn't an equipment grounding conductor, but there was a grounded conductor. So, obviously, we have an exception here, and it's for existing branch circuit installations only. And again, you've got the rules you have to follow, the caveats that you have here, and these are the ability to connect to the grounded circuit conductor under these conditions. And there's 4 different conditions here. That's for existing only, not for new installations. So again, hopefully we don't see that in new installations, but you do have the allowance here for the existing installations. Other than that, I need to see 4 conductors, a 4-conductor cable being run to the ranges, to the wall-mounted ovens, to the counter-mounted cooking units, cooktops, and clothes dryers, as well as to the outlets if they are have an outlet and it ends up being a direct hardwire from there, which is very common with cooktops and whatnot. Again, still applies. We have to make sure we run these circuits now, and we have the 2 ungrounded, the grounded, and an equipment grounding conductor. Okay. And I think we all do that today. But again, there's still the misconception. People go into the big box stores, not to talk negative about them, is the Lowe's, the Home Depots, the Menards, and things like that. And they buy the wire, and you've got the people that are there to try to help you, the people that work in the aisle. But they might not be up to the changes here, because they might be people that have retired. I'm not saying this in all cases. I don't want to hurt anybody's feelings, but maybe they were very relevant in the industry back prior to 96, but now they're retired and they're supplementing their income, and that's perfectly wonderful. I'm glad people are working, but they might be giving advice that is not totally accurate. So we have to be aware of that. So that's probably something that still comes up today, and we have to be aware of, and that is obviously a serious mistake. Okay? All right. I guess the next one that we'll look at is one that, be honest with you, personally to me, I haven't run into a lot, but obviously it made it the list, and I can see where it would be an issue, is that I like to use the term back in the day. So back in the day, before we got more complex when it comes to things like grounding and bonding, and a lot of things really changed on Code Panel 5 for the 2008 cycle. Prior to that, really a lot of info, but a lot of things, the stars started aligning for those that served on that panel around 2008. That's my opinion. So others can agree to disagree, but that would be my opinion. And so we started to see terminologies aligning. We started to see structure of 250 better in alignment. And we also started to think about things that were, whether something was accessible or not, whether or not you could skirt a rule because it wasn't considered accessible. However, it did create a ripple effect of other problems. And one of those might be for the submersible well pumps. Okay, so as it says in the article, and I encourage you again to go check this article out at ECNM Magazine, and I never gave this much consideration, was that many years ago you could have a well pump, and the well pump would only be a 3-wire setup, and it wouldn't have a dedicated equipment ground. So after 2008 NEC, a fourth equipment ground, or the fourth conductor for the equipment ground, was required, and now a lug at the top of the well casing is required. These are things that have changed over time, and my fear is a lot of well pump applications, they might go into the application and simply just install a cable without, for example, an equipment ground, because it was allowed and permitted. And for years before 2008, clarified, and that is something that probably, depending on where you're at in the country, probably still a practice. Although today, most of the cables that we buy or produce are more than likely going to have an equipment ground. Now, there's an exception to that rule. Again, so for example, tray cable, you can buy tray cable without an equipment ground. Now, the reason you can buy that without an equipment ground is because if you're using that tray cable inside of a cable tray, and the cable tray itself qualifies as an equipment ground, well, then there you go. You have allowances in the code in order to be able to do that. Obviously, if the tray itself qualifies under 250.118 and item number, I believe, 11, then there you go. You've got it. But only if it qualifies. So there's so many aspects of that we have to think about. But I think one of the issues is we want to guard against is people that are not up to date on the changes to the code. And so, again, if you follow along, I'll kind of read it to you so you can see where this is. So you just kind of follow it. When we're talking about equipment grounding and equipment grounding conductors, if you kind of go into the National Electrical Code and you go under 112, it says specific equipment fastening in place, fixed or connected by permanent wiring methods. And then you read down and it says, except as permitted in 250.112F, okay, F and I. On F is garages, theaters, and motion picture studios, and I is remote control signaling and fire alarm circuits. So other than those, it says exposed, normally non-current carrying metal parts of equipment described in 250.112A through K, and I'll get to the point in a minute, folks. It says the normally non-current carrying metal parts of equipment and enclosures described and, blah, blah, blah. So if the key that I would say is you go down and you look at L and you look at M. L is motor-operated water pumps. This is motor-operated water pumps, including the submersible type. And again, this is all talking about, again, having all the equipment ground and all the non-current carrying metal parts, as described here, connected to an equipment grounding conductor, regardless of the voltage. But then you also jump to M, and M says metal well casings. It says where the submersible pump is used in a metal well casing, the well casing shall be connected to the pump circuit equipment grounding conductor. Okay, so you're going to have that equipment grounding conductor run. Now, so code evolution has changed, and we have a better understanding. Again, the whole purpose of an equipment ground is to be able to clear an overcurrent device. A byproduct of that is it also serves a bonding function and bonds metal parts together. Okay, so that's why we're so diligent in how we make our connections to metal boxes, to the devices, splicing. All those type of things are very important. And I think this article here just pulls out the fact that in many, many, many cases, people would have an application to a submersible well pump where they would not have an equipment ground. And that can be a significant concern. Okay, so just keep that in mind. I think today it's probably not as big of an issue as it might have been even back in 2014. But again, if you're a guy that does this out on farms or out in somewhere rural and places where they don't have inspections, then this is incumbent on you to make sure that you're dealing with these installations safely. Okay. All right, the next one that we probably want to look at is probably something that happens an awful lot. And I'm going to kind of divert a little bit and go on to a tangent. Not big one, trust me, don't worry. But it's about, like home inspectors and flipping and people that flip houses and whatnot. But again, dealing with the way it's presented in the article, for example, it's stated, and this is, again, number 8 if you're counting in our 10 list, it's improper replacement of a non-grounding receptacle. So in older homes, you'll have older systems like the old BX systems, which is an armored type of system, but the armor itself never qualified as an equipment grounding conductor. Now, again, if the receptacle in the BX is close to the panel, close to the first receptacle, and you put one of those testers in, it probably will work, and it probably will have a low enough impedance to clear a device, maybe. But it was never evaluated as that, so many people around the country are using the BX, okay, which was a experimental cable that was put out many years ago by, I think it was GE, and it kind of was a precursor. And people want to call this AC cable, and that is not accurate, right? AC cable's been around a long time. That's UL4. However, when AC cable came out, it utilizes the armor as an effective ground fault current path because it has a bonding strip in there, okay? BX typically, whether it had a strip or wire in it or not, was not evaluated for such situations. So it really wasn't evaluated for it, but people want to literally utilize it. And you have to remember why we know it wasn't evaluated. And that is typically when you see the old BX cable, you go to the receptacles and you've got what? We have a 2-prong receptacle. So there was no foresight in that. There was no thought of, do we need to worry about equipment grounding? Because there is no equipment ground terminal on these devices. So there was no thought that we needed to use the armor as such. Well, with AC, that was a thought that the armor, because of the internal bonding strip or wire that makes intimate contact with the convolutions all the way through the cable assembly, that basically, rather than the fault current having to follow a curvature path back to the source and creating a lot of impedance along the way, that what happens is it creates a direct path through the linkage of that included strip or wire that is intimately in contact with the convolution, that it allows the overcurrent device to function. That wasn't the case with BX, although there's a lot of it out there. But this issue here that they address has to do with an improper replacement. So we have a house. Let's say the house has the BX in it, or maybe even the house has the older style non-metallic, okay, that maybe did not have an equipment ground in there, or it had inadequately sized the first generation where we had that really, really small wire in there, okay, which is when they started to think maybe we need an equipment ground. Anyway, let's use an example where we have a receptacle in an old house that has, it's just a non-grounded type. It has 2 prongs. That's it. A grounded conductor side and a ungrounded conductor side, right? In this case here, homeowners, people that do flips, people, contractors who don't know any different, want to go in and they want to pull those out. They're not changing the wiring, but they pull those out. They want to put in, all of a sudden, a 3-prong with the grounded terminal, with the grounding terminal, equipment ground terminal, because that, again, is more optimized for the different appliance that we have today. But, of course, those appliances with the attachment plug that has a ground pin on it are trying to utilize that ground pin. So when you replace one with a 2-prong receptacle, let's say, with a 3-prong, but you really don't have an equipment ground there, you're doing a disservice to the consumer because they're under the false impression that there's an equipment ground there. Next thing is that a lot of times what these people will do, and I'm not saying that the concept again comes back where the customer goes, yeah, but maybe I don't need that equipment ground because that grounded conductor goes back all the way to the source. And since that's the same location that the equipment ground would go, I don't need it. And they end up looping it over and creating what's called a bootleg ground. So they basically make a connection between the grounded conductor to the grounding terminal. And the breaker's not going to know any different. The function's going to function. The only problem is when you plug the appliance into this receptacle, now you're potentially energizing metal parts because of the connection that's being made at the device. And it creates a hazard in that aspect. Now, there are ways to correct this. So if I was telling somebody, obviously they call this out as a really big deal, and it is, you have options. So when I'm doing a replacement, for example, if you're following the code 406.4D, and I'm in the 2020 edition, it tells you grounded type receptacles, then it goes on to non-grounded type receptacles. And it gives you an A, a B, and a C. Obviously, one option is to take one of those non-grounded receptacles out and replace it with another non-grounded receptacle. Now, I'm not sure why you would do that unless it's just damaged and you're just kind of maybe fixing up the house for resale, but you're not messing with the wiring and you notice there's a broken device. Yes, I'd encourage that. Replace the broken device. I get it. However, it's not appropriate to just immediately throw a 3-prong receptacle in there to give the appearance of an updated electrical system. Now, you do have options to put a GFCI device there. You do have options to put a GFCI device upstream, let's say in the panel, provided the house can even accommodate that, because obviously if it's old wiring and it's still an ungrounded system, I shouldn't say that, excuse me, a system that does not have a grounding system on it, because it's a 2-pin or 2-prong, you're giving this false impression. Okay, so obviously, what are you supposed to do in this scenario? You can use GFCI devices in the panel or at the device, but you have labeling requirements. And in those rules in 406.4D2, there's a B and a C, which has labeling requirements. I encourage you to look at those. We're not going to go into detail today. I've done that many times in other shows. But you're going to have the label because you need to tell the consumer that there isn't a ground present, right? But it is GFCI protected. Now, I won't get into the debate whether one is better over the other. There is 2 different camps on that. I know that the code requires an equipment grounding conductor. When one is not there, then you do this. Now, you do have other options. I mean, I could literally get me an equipment ground there, and I have some allowances in the code that will say, look, 251.30 will let me get an equipment ground there if I want that route. But in this case, you have the ability to use a GFCI, ground fault circuit interrupter, to be able to achieve this. And you have options, whether it's in the device box or whether you do it at the panel, if that is ability to do that. If the panel's not dated to a point where you really can't find one that goes in the panel, then your option would be at the device. So you've got rules to follow. I think that the biggest issue here is improper replacement. and that is the hairy homeowner. And then, again, nothing against you. Homeowners are allowed to do their work. I don't see homeowners doing this. I think I see the handyman, and the handyman wants to dabble in electrical, and they go, I'll just replace it and put a 3-prong. What's it going to hurt? That's the problem. And then when they go over the top and they have just enough knowledge of electrical to say, well, I'll just put a jumper over to the grounding conductor and it'll fool those little 3-light testers. Now, it won't fool those nice sure tests from Ideals, but the little 3-light testers, it will fool it all day long in a bootleg ground. And that's never a good thing. Okay. So at the end of the day, I think the biggest takeaway here is if you're going to replace a non-grounded receptacle, you do have options under 406.4D. Make sure you follow them. That's the key. Okay. Okay, the next one that we're looking at is probably one I don't see as much today when it comes to the water piping system inside of a building, but we do see a problem for the connection when it is present. And we're talking something totally different than the water pipe ground that qualifies as an electrode. That is the 10 foot in contact with the earth under 250.52A1. We're not talking about that. What we're talking about here is the bonding of the metal water piping that might be in your dwelling. Okay, so if you have a dwelling and it's all, let's say, copper, everything, then you're required to bond the water line. So in this bond, many people tend to use the wrong types of clamps. They use a clamp that might be listed for rods, but not for water pipe, and vice versa. So in this case, talking about the issue that comes up with water pipe grounding, or bonding, I should say. Got to be careful. Water pipe bonding, that's the only way you can separate the two. Because, again, one's an electrode aspect, and this one is the bonding of the water line. Here's what the code says. So if you're following along, it's 250.104A1, and it says, metal water piping, a metal water pipe system shall be bonded as required in 250.104A1, A2, or A3. So A1 says metal water piping systems shall in or attached to a building, so if it's running on the side of the building, in or to a building or structure shall be bonded to any of the following. So we're bonding this metal water piping system. We're not talking about a PEX system. Obviously, that's not metal. Again, okay, you probably all get that. But if we have a metal water piping system, maybe it's a galvanized, or maybe it's copper water piping system. I don't know. Depends on where you're at in the country, right? So number one, it says I could bond that water piping system to the service equipment enclosure. Okay, so that would be the service equipment where your main breaker is, your panel board's inside of this cabinet, and yada, yada, yada. I can make a connection there to the service equipment enclosure. Why? Because we should have a main bonding jumper at that enclosure connecting the grounded terminal and the grounded conductor to the case. And then all my equipment grounds come back to that terminal or to that bus, which is intimately connected to the case as well. All of this being done through a main bonding jumper. So obviously we could do this bonding. We could come back to the service equipment enclosure. Okay, so that's an allowance. That's one of them. The next one it says is I could go to the grounded conductor at the service. So I could come back and make a connection to the grounded conductor, which ultimately you could go back and connect to the grounded terminal bus, and it just is, it's the same scenario, right? What I don't want people to read this into thinking they got to tap onto the grounded conductor. It's not. Don't do that, okay? Next it says, 3, it says grounding electrode conductor if of a sufficient size. So that means that, you know what, I can actually bond the entire water piping system back to the grounding electrode conductor, provided that is of adequate size. You know, because you could have a grounding electrode conductor, for example, that is sized to a ground rod that might be only 6 gauge based on 250.66A, but sizing the connection, the bonding jumper from the water pipe to that grounding electrode conductor might ultimately not make it the right size. Because when you go back to that grounding electrode conductor, where is it going? It's going back up into the panel and making that connection to the grounded terminal point. Okay, so you're just using that grounding electrode conductor as the extension to that grounded terminal point. Okay, I get it, but it's got to be adequately sized. And if it's smaller than what you would normally calculate for the need for the bonding jumper, then you've got a problem, right? If the grounding electroconductor you're using to facilitate that connection is not properly sized. So you got to think about that, right? And in number 4, it says one or more grounding electrodes used if the grounding electroconductors or bonding jumper to the grounding electrode is of sufficient size. Okay, so all about the size. That's critical, making sure you do that. I think what most people do with the interior water pipe, if it's metal, is that they will go back and make the connection back to the panel. I think that's probably what we see the most, right? And in most people, probably go in the panel and they will take it right to the grounded terminal bus. I mean, that's where most people will make that connection. Now, it says the bonding jumpers, okay, we're reading on, and if you're following along, 250.104A1, underneath it, it says the bonding jumper shall be installed in accordance with 250.64A, 250.64B, and 250.64E. It says the points of attachment of the bonding jumpers shall be accessible. Okay, so you got to be able to get it. Doesn't say readily accessible, it does say accessible though. It goes on to say the bonding jumper or jumpers shall be sized in accordance with table 250.102C1, except that it shall not be required to be larger than 3/0 copper or 250 kcmil aluminum or copper-clad aluminum, and except as permitted in 250.104A2 and 250.104A3. So we get the reference to go back to size this jumper all the way back to 250.102C1, with the exception that was added saying, look, you know that table also has the provision for 12.5%. It's saying, look, do your normal due diligence based on the size of the conductors that are supplying the system, and then go size your bonding jumper in accordance with 250.102C1, but it doesn't have to be larger than 3/0 copper or 250 kcmil aluminum or copper-clad aluminum. So ultimately, that would be the maximum size it would need to be, right? So just be careful. I think the problem here is twofold. One, people don't use the right connections. They don't use the right devices. They don't look at the listing and what they're listed for. And two, I think that many people don't know how to size it, which, again, if you always go 3/0 copper, who's going to do that? But if you did, you wouldn't be wrong, but you'd be oversized. And again, being that we're very price conscious today, it's probably not the route. You need to know how to use 250.102C1. But just remember that 250.102C1 is based on the conductors that are supplying the system. Okay? So all of that type of scenario is going to be sizing that jumper, and you're going to use that, and that's where you get all your direction from that. Again, based on the article, I think mainly the problem is the improper use of clamps. They do make, for example, water pipe clamp that also doubles for ground rods, but not all of them do. So just got to be very aware of that and do your due diligence on that. But I think the biggest thing people see is the improper or wrong use of clamping. I just wanted to point it out the fact that also a lot of people don't bond the metal water lines inside of a building like they're supposed to. Okay. But again, today, most of it's probably non-metallic, so it's kind of a moot point, but just be aware of it. The next thing that it talks about in their list, and again, that was number 9, we're at 10, is not installing GFCIs where required. Now, we are seeing a major expansion in GFCI locations, and you've probably been familiar with it. And, again, GFCIs do function. You have this broken down in 210.8, and this is very much a device application here. And if you look at it, when it starts out device, but then it kind of moves on. So you have 210.8A, dwelling units, 210.8B, other than dwelling units. Of course, then you get into C, crawl space applications, D, specific appliances that are listed in 425.5, like dishwashers and all that kind of stuff. And then you get E, equipment requiring servicing locations. And then, of course, F is outdoor outlets. The key thing here is I think what we see is because this is an ever-changing section within 210, for GFCI protection, you're seeing more and more and more aspects of requirements for grounding. And I hear a lot of people, I really do, on a lot of their podcasts and videos who talk about GFCIs as being so triggered to water. This is not necessarily true. It just so happens to be a coincidence that most of the locations where GFCI rules, and again, it's not GFI, they're GFCI, a ground fault circuit interrupter, which is not to be confused with GFP, with this ground fault protection. Totally different milliamp thresholds than what a personal protective device like a GFCI type A or class A type of device that's going to protect me, okay, as a person. It's big different than a GFP, which is more about equipment protection, and it could be 20 milliamps or even higher thresholds depending on the manufacturers, right? So distinct difference. But one thing that really changed, that the flipper, the homeowner, the do-it-yourselfer, the service person who maybe not be as so in tune with the code, is that we've had a dramatic change on the GFCI requirements based on the voltage as well as the amp rating. For example, in 2020 code, it says all 125 volt through 250 volt receptacles installed in the location specified in 210.8A1 through A11. And if I had to give you any heads up for what's coming, if you want like a little sneak peek at what's coming in the 2023 edition, unless you get involved, and right now the public comments are starting soon, you're going to be required to have GFCIs everywhere. I mean, even the bedroom receptacles, hallway receptacles, even your ranges and your dryers and everything. Even though there was a provision for that depending on proximity to sinks and stuff, it was a provision for that in the 2020. You're looking at the 2023 really just opening the door on all the GFCI location requirements. And the reason I tell you is that everybody talks about it, a relationship to water. And I've argued for years for people that it is not a relationship to water. And now I can tell people, you know that I'm right, because in the 2023, why does that relationship have anything to do with the receptacles in a bedroom or in the hallway or in the living room? There is no relation to water. Okay, it is all a relation to the fact that GFCIs are to eliminate ground fault applications and to clear a device. Anything that is below 4 milliamps or less, it's not to activate. Anything that's 6 milliamps and greater, it's to activate. We use 5 as the nominal bridge point, right? So at the end of the day, it's less about water. Even though within 210, we're very conditioned to say, well, all these locations might be in proximity to water, but we're not really the case here. The garages, it's not about the water. It's about the concrete floors and people being barefoot on it and all this kind of stuff. It's not directly about water. The basements. Now, people argue, well, the basements could flood. They're not going to flood if it's sealed in right and it's properly done, okay? At that point, we're trying to be prognosticators of what could happen. So it's less about the water aspect of it. Now, you do have the one for sinks in item 7. I get it. You got the one in 9 for bathtubs and shower stalls. I get it. You have laundry area, which people think that obviously the washing machine is just all of a sudden going to just leak everywhere and now there's a ground fault condition. I get it. But at the end of the day, bathrooms, obviously sinks. But again, it doesn't really matter because any receptacle in the bathroom would have to be GFCI protected. So point being, it's less about water. It's less about where the code tells you GFCI has to be. And we know this is true because all we have to do is look and see where GFCIs are going for the 2023. It's been a slowly increment. Now, it's not that I say GFCIs don't work, because I do, but obviously they work. Okay, we have plenty of history, great technology, but it's now going everywhere. And the key here is it's going to apply to all 125 through 250 volt receptacles. This is going to raise the cost, and I didn't want to get into cost, but you think about a panel now that's going to be loaded with AFCIs, loaded with GFCIs. The standard breakers pretty much going the way of the albatross, right? Of course, you do have the option, again, putting a standard breaker in and put a GFCI at the first outlet. I still get it, okay? Not something you're going to do for ranges. Obviously, you're not going to put that based on where the receptacle would be anyway. Even if they did come out with one, it wouldn't be accessible. So, and we could argue that, well, it doesn't matter because GFCIs have to be readily accessible. And then that wouldn't be the case. It would not be ready. So, I mean, that's not going to happen. So that's going to push you to a circuit breaker. And again, obviously they're available. But again, this is going to rapidly raise the cost of construction. And right now in this industry, we can't even get the supplies we need. The cost for non-metallic sheet cable now has gone through the roof because of supply and demand. This is not going to change. And I don't foresee this changing in the next year or more. So being able to get product, the prices are going to be going out of the roof. It's going to drive many contractors into not taking on projects because of they just cannot get the material. Well, in this case, you're going to have the increased cost of these GFCIs. Okay. And that's going to drive cost up. Not to mention there's been other things that are driving up costs, and I get it. This is a safety thing. I understand. I get it. But at some point, we have to have more historical data than we do just gut pulling data. And that is like, well, we have GFCIs everywhere. We might as well expand them because we want to save everybody from themselves. So I said I wouldn't go get on a soapbox on that. But again, just be aware that it's coming. But again, not installing GFCIs where they're required is not a good thing. And I think it's because these rules are ever changing, and homeowners, flippers, handymen, things like that. And again, nothing against it. God bless them. We need them. But they're not up to these rules. So as an electrician, educate, let people know. I just kind of touched on some of these things, but it is definitely stuff that you want to make people aware of because it is a real concern. And we want to make sure that these grounding issues, these safety issues are mitigated long-term. So everybody, I hope you got something out of today's podcast. Hopefully I didn't rant too much at the end. I appreciate you listening to all of our podcasts. You can listen to them over on Spotify, Deezer, iHeartRadio. You can listen on our website, masterthenec.com. You can listen over on the YouTube channel. We put all of our podcasts up there. It'll say podcast in the little thumb tag, so you know you're not getting a video, but a podcast. Share it with people. Love your comments. Give us 5 stars. Give us good reviews. We appreciate you. It's a lot of work it takes to carve out time to do these things. And if you're thinking about studying for the National Electrical Code and you want to get a more in-depth understanding, we'd love to see you over in our Fast Tracks program. It's available over on masterthenec.com. And if you want more information about it, there's a video there and you can learn about it. Again, thanks for listening. Until next time, stay safe. God bless.
Shut up and sit down.